Let's do some example problems with our valence bond theory and all of our geometry and tie it all together. All right, so I've got 4 practice problems here. We're going to look at a few different molecules. We will draw a Lewis structure and start assessing all of that. So when you look at these types of problems and you're trying to figure out the geometry and the hybridization and explain that with our orbitals and our mixing and everything, there's some steps that we want to take. First, we want to draw the Lewis structure. Okay. Second, we want to assess the geometry. All right, and then third, we'll draw our orbital diagrams. All right, so let's start. So I have methanol here. So we'll draw a Lewis structure. Now methanol is interesting in that we're actually going to have to consider what's happening both from the perspective of the carbon and the oxygen. So hopefully you recall back to your prep chem classes where you can look at a molecule that has basically more than one central atom, because that carbon has 3 hydrogens and an oxygen around it, and that oxygen has got the carbon, a couple lone pairs, and a hydrogen. So from the perspective of my carbon, I have my central atom and I have 4 things bonded to it. So this is orbital geometry that is tetrahedral. From the perspective of my oxygen, I have my central atom, I have 2 things bonded, and 2 lone pairs. So my orbital geometry here is also tetrahedral, which means that for both of these, we're going to need 4 places to put things. All right, so let's look at the carbon first. All right, I have my 2s and my 2p, 1, 2, 3, 4 valence electrons. Okay, we're going to take all of this because we need 4 places to put things. We'll mix. Okay, and we'll get what type of hybridization? sp3. All right, and we'll go 1, 2, 3, 4. And all of these will be bonding. Okay. Now let's look at the perspective of the oxygen. I gotta give myself a little more room here. All right, so my oxygen. I got my 2s and my 2p, my 1, 2, 3, 4, 5, 6 valence electrons. I still need 4 places to put things, so we're going to take all 4 of these again. We'll mix them. Okay. And once again, we'll get sp3. 1, 2, 3, 4, 5, 6. So here are my lone pairs. And here are my bonding. All right. Okay. So here's our next one. I want you to try this on your own before you look at my solution. So pause and try this one. See if you can do it. Okay, let's see how you did. We'll draw our Lewis structure. All right. We'll assess that orbital geometry. I've got a central, I have 4 bonding, and I have 1 lone pair. So my orbital is what? Trigonal bipyramidal. Okay. All right, so we have our 3s, our 3p, our 3d. Okay, sulfur has 6 valence electrons, so we have 1, 2, 3, 4, 5, 6. All right, we need how many places to put things? 5. So we're going to take this, one of our D's, and mix. Okay, what we'll be left with is our sp3d and our unhybridized 3d leftovers. Okay, we have 6 valence electrons. 1, 2, 3, 4, 5, 6. All right, so this is going to be my lone pair. And then this will be my bonding. Okay. All right, here's the next one to try. Okay, so again, pause, try it, then unpause. All right, let's see how you did. So we'll draw that Lewis structure. Okay, so silicon, our geometry, I have my central, and I have 4 surrounding. So my orbital geometry is tetrahedral. Okay, now we can do our orbital diagram. So I've got my 3s, 3p. Yes, silicon would indeed have our 3D orbitals existing, but because we don't need them for the hybridization, I didn't put them in here because we don't need to show them when we look at hybridization if we're not utilizing them. So I have 4 valence electrons. It'll look like that. And I need 4 places to put things. So we'll take all 4 of those. We'll mix. And we'll get our sp3. So I have 1, 2, 3, 4. Everything's a single bond. And so this is all bonding. Okay. All right, last one. So try, I guess, unpause, and then see how you did. Because remember, you're never going to learn this if all you ever do is just copy down what I or somebody else does. You have to try these on your own. You have to. There's no getting around it. You cannot learn something without working it on your own. All right, so let's start with that Lewis structure. Okay, so let's assess that geometry. All right, so I've got my central atom. I have 4 surrounding, and I have 2 lone pairs. And again, with these, the shape, the molecular geometry of these starts to differ once we add in lone pairs. But when we're looking at hybridization, we're concerned with the orbital geometry, the total number of electron groups that exist around that central atom, because that tells us how many places we need to put things. All right, so our orbital geometry is our octahedral. Okay, so xenon, we're going to get 5s, 5p, 5d. Xenon is a noble gas, which means we have a full valence shell. So we've got 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8 electrons. Octahedral means we need 6 places to put things, so we're going to take the S, all 3 P's, 2 of the D's, and we'll mix those. Okay. So we're going to get our sp3, D2, and 3 left over 5D that we do nothing with. Okay? All right, so 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. We've got 2 lone pairs. And now we have all our bonding. Okay? So those are our examples. So you need to know how to do all this stuff.